Hello students, as you all know that we have finished the chapter called coordination compound in the last class, isn't it? So now we'll bring the physical chemistry portion and we'll be doing a new chapter called electrochemistry. And it is one of the very important chapters, students, keep this in mind. So it's a very important chapter. Okay, it contains objective question, it contains numerical problem, it contains reasoning question, so many things are there inside this chapter. And this chapter usually counts for 6 marks. But one of the year it has even come for 11 marks. I repeat again, this chapter usually counts for 6 marks. But one of the year this chapter has come for 11 marks also. So let us see what are the topics to be learned under the chapter called electrochemistry first. Topics in electrochemistry are these all 5 topics you have to learn. Conductance, Faraday law, conductance, Faraday law, galvanic cell, battery and corrosion. Okay, so these are the 5 topics which constitute the chapter called electrochemistry. Conductance, Faraday law, galvanic cell, battery and corrosion. Okay, usually these are the 5 topics present inside this chapter. But due to COVID-19, now this too has been reduced from the syllabus. That is chapter 4 and 5 is not, topic 4 and 5 is not there in the syllabus. That means you don't have to learn about battery now, you don't have to learn about corrosion in this reduced syllabus. But you need to learn about the first 3, that is conductance, Faraday law and galvanic cell. And do remember students, all these 3 are very important chapters. Okay, all these 3. It contains objective questions, numerical problem, it contains objective question, numerical problem. It also contains objective question, numerical problem along with reasoning questions and answer. So these all 3 topics are very important. That is conductance, Faraday, galvanic cell. All 3 are important. But in most of the time in ISC, what you observe is this has been given most of time. That is galvanic cell. Done. So out of these 5 topics, 4 and 5 is been reduced from your syllabus now. You have to learn the first 3, which is very important. In which in ISC mostly they give galvanic cell. But we should not ignore the above 2 also, that is conductance and Faraday also has to be learned, because from there also objective question can be asked, even the numerical problem. So when we go with the syllabus, students, I am going to teach you first is conductance, then we will learn is about Faraday law, then finally we come with the galvanic cell. So first we are going to learn is conductance, then we learn is Faraday's law, then finally we go with the galvanic cell in this particular chapter. Done? Now students, do remember this has been asked mostly, and in your book also if you see, usually the teacher teaches galvanic cell first, then Faraday law, and finally they teach conductance, but I go opposite. So please have patience for that. So I am going to teach you is first conductance, then Faraday, then galvanic cell. So hope so you understood about the topics inside the chapter called electrochemistry, which are in the syllabus, which are not now, and which are the important chapters, topics of the chapter. Done? Now, before we start this chapter, let us see what is the meaning of electrochemistry first. Many teachers says, okay, we're going to start a new chapter called electrochemistry, and they start. But what is electrochemistry all about? You can see in the name only, you can find the clue, okay? It is a chapter which is based on influence of electric current, electro means electric current, in a chemical reaction, okay? So afterwards, if you take electrical engineering, okay, in physics, that there also this chapter plays a vital role, okay? So what is electrochemistry chapter all about? It is the chapter which is based on influence of electric current in a chemical reaction. Because in chemistry we discuss about chemical reaction, isn't it? So how the current is going to affect the chemical reaction, that we are going to see under this chapter. So what is electrochemistry all about? It is a chapter based on influence of an electric current in a chemical reaction. Okay, this is the meaning of the chapter called electrochemistry. The influence of electric current we are going to observe in a chemical reaction. Now, before we start the topic, let us see this part. One question for you all. How does metallic conductor and electrolytic solution conducts electricity? Even metal conducts electricity, even the solution conducts electricity, but how they conduct? Do remember students, metallic conductor, they conducts electricity. Metallic conductor, they conduct electricity through movement of electrons, because metal contains electron in them. Whereas electrolytic solution conducts electricity through movement of ions. I have written here, metallic conductor conducts electricity due to movement of electrons, whereas electrolytic solution conducts electricity due to movement of ions. So do remember, metal they conduct electricity through movement of electrons, whereas solutions they conduct electricity through movement of ions. So I have introduced a chapter called electrochemistry with you so far. So out of these 5 topics, now we are going to start is with conductance first. Okay. After completing conductance, we go to the Faraday, then to the galvanic cells. So let us start conductance from today. Okay, from today we are going to start is conductance. And just now I said you, metallic conductor, how they conduct electricity? Through movement of electrons. Electrolytic solution, they conduct through movement of ions. So now we are going to start is the topic called conductance. But again, before we start conductance, students, you should know some difference between physics and chemistry here. So this side I made it physics portion, this side the chemistry portion. Okay. The very popular letter in physics is capital R in electricity. And what does this R stands for? Resistance. We have heard in physics. Capital R means resistance in physics. And what is its job? To oppose the flow of current. The job of resistance is to oppose the flow of current. Done? And its unit is ohm, OHM, ohm or omega. This symbol is called omega. Okay? This symbol we call it by the name omega. Okay, we call it by the name omega. So in physics we learn about capital R, which is resistance. The job of that is to oppose the flow of current. Done? And its unit is ohm, or we can say omega, and it opposes the flow of current. And we have already learned in physics there is a law called law of resistance. Now let us say what is this law of resistance. R is directly proportional to L but inversely proportional to A. So R is directly proportional to L and inversely proportional to A. Now what is this L and A? Let us see. This L stands for length of resistance. And when we consider length, we either take it in centimeter, in CGS system, in meter, in SI system. Okay, now what does this A means? A means cross-section area of resistance. Cross-section area of resistance is called A in physics. And since it is an area, so the unit will be centimeter square in CGS system and meter square in SI system. So let us consider, I think you all have seen the resistance, isn't it? So this is the resistance. And whatever is the distance, this is the length of resistance. And this portion is called the cross-section area of the resistance. This is called by the name cross-section area of the resistance. Length unit is centimeter or meter. Cross-section area unit is centimeter square or meter square. And law of resistance says that resistance is directly proportional to its length and inversely proportional to its cross-section area. I repeat again. Law of resistance says that resistance is directly proportional to the length and inversely proportional to the cross-section area. Means more the length, more the resistance, less the length, less the resistance. More the cross-section area, less the resistance, less the cross-section area, more the resistance. Also you all understood this relation. And as per the rule, when you convert proportional sign into equal to sign, a constant will come. So now R is R, L by A is L by A. So I am replacing proportionality sign with what? Equal to sign. When you do so, a constant has to come. And the constant here, what we put here is rho. When you open proportional sign into equal to sign, here the constant what we put is rho. Now let us see what is this rho stands for. This rho means specific resistance or resistivity. I repeat again, this rho means specific resistance or resistivity. And now let us see its unit. Since I have already said you the unit of R is ohm or omega, L is centimeter or meter, E is centimeter square or meter square. Now we are going to see is the unit of rho, which is actually specific resistance or resistivity. Done? Now, so what we do out here, students, we will take this A this side. So R into A by L will go down, and what remains here is simply rho. Just cross multiplication. R into A is here. This L will go down. R into A divided by L will go down. What remains here is rho. And this gives you the formula of specific resistance or resistivity. Okay, R is equal, rho is equal to RA by L. Now let us find the unit of specific resistance or resistivity here. As you all know, the unit of resistance is ohm, so I am putting out here. Area unit is centimeter square, so I am putting out here. A means area unit is centimeter square and length unit is what? Centimeter. Done? Now here we can cancel this centimeter with one of them. So if you get cancelled, so what remains is ohm centimeter. What remains here is ohm centimeter, the unit of specific resistance or resistivity. Now what if I put here in SI unit? Ohm will remain as ohm, but here will be meter square and here will be meter. So if you cancel that, then meter and meter square will get cancelled, so the unit will be ohm meter. So the CGS unit of specific resistance or resistivity will be ohm centimeter and SI unit will be ohm meter. And you have to remember these all units for the numerical problem. Even the units are asked in objective questions. So for that reason you need to remember this. Done? So this much is all about physics. So remember the unit of resistance, L and A unit. What does rho mean? Specific resistance or resistivity. And you remember the unit of this is O centimeter or ohm meter. And students, to remember the formula of resistivity. So tell me, what is the formula for resistivity now? R A by L. Okay. So what is the your formula for resistivity or specific resistance? The formula for specific resistance or resistivity is R A by L. R A by L. But how to remember this? You can remember this way. Ra 1. In Hindu mythology, we call it by the name devil. Ravan is a devil. In Dasara, you know, this devil has 10 heads. So Rama, okay, has killed that person in Dasara. So that's why we celebrate that day. Okay, because he went to get Sita in Lanka. You all know that about. So here I am writing Rho is equals to Ra1. Ra1. So formula of resistivity. Specific resistance from today is Ra1. Ra, Ra1. Well, R means resistance, A means cross section area, and actually it is not 1, it's L, but we can call it as 1 only right now, and that is the length. Hope so you all understood. So I hope you understood the topics to be learned under this chapter. What is the chapter based on, and what is the difference of conductivity between metallic conductors and electrolytic solution? I explained you, and I taught you a little bit about physics. Now we come to the chemistry portion, and we are going to learn is about conductance. So conductance symbol you can give it by C. In CBSE book it is given by G. Conductance symbol in CBSE book is given by G, but here we go with C. So what does the capital C means? Conductance. And what is this conductance? It's opposite of resistance. Resistance opposes the flow of current, I have already said you, whereas conductance allows the flow of current. That's just opposite. If the door is shut, can anyone come inside? No. Means that door is acting as a resistance for that particular person, because that person cannot come inside because door is locked. What if door is open? The person can come in, so that is conductance. So closed door will block the person to come in, so that is resistance. Open door will allow the person to come in, that is conductance. So they are reciprocal to each other. So resistance opposes the flow of current, whereas conductance allows the flow of current, which symbol is C. So from this definition we can say that they are reciprocal to each other. So conductance is opposite of 1 upon resistance. Okay. So conductance is opposite of 1 upon resistance. Hope so you all understood. They are reciprocal to each other. Now let us see the unit of conductance again. So many units will come out here, students, and all other derived unit you have to remember it. Okay. Now let us see the unit of what? Conductance. So conductance is 1 upon resistance. 1 is 1. Resisting unit, what we wrote here is ohm. So write here ohm. So 1 upon ohm is the unit of conductance. 1 upon ohm is the unit of conductance, and you know that if ohm goes up, become ohm inverse. So that means if the resistance unit is ohm, then the unit of conductance will be ohm inverse. If the unit of resistance is ohm, the unit of conductance will be ohm inverse, because if ohm goes up, become ohm inverse. Similarly, if the unit of resistance is omega, put here omega, then the unit of conductance become omega inverse. Okay, so unit of resistance is ohm or omega, whereas the unit of conductance will be omega inverse or your ohm inverse. Now another two units are still left. Let us see what is this. From here you can see, students, OHM means ohm. Ohm means what? Resistance. Read from back. MHO, mho, that is conductance. So if OHM, ohm, is resistance, then MHO, mho, is conductance. Opposite. So here only I have written that only, students. MHO, mho means what? Conductance unit. So if ohm is the unit of resistance, then mho becomes the unit of conductance. Just opposite. OHM, ohm is resistance. MHO, mho is conductance. And do remember, these all are not the different unit, these all are the same unit. So whether you write ohm inverse when you do the calculation part, or whether you write omega inverse or mho, it's same. Or else we can even write by the name Siemens, okay, whose symbol is simply S. So whether you say ohm inverse, omega inverse, mho or Siemens, that is S, all are the unit of conductance and these all are the same unit. So do remember all these four, and all of these four means same unit. Okay, students, so from physics we are slowly entering towards chemistry now. So resistance and conductance is reciprocal to each other. So from the unit of resistance we got the unit of conductance. Okay, and ohm is resistance, mho is conductance, and it is also written by the name Siemens, symbol S. Now let us see this small k out here. This small k means kappa, not appa. It's kappa, small k. Small k means what? Kappa. And what does this small k means? It means specific conductance or conductivity. If rho is specific resistance, then kappa, this is called by the name kappa, not k, we call it kappa, is called specific conductance. So if rho is specific resistance, then kappa is specific conductance. If rho is resistivity, then kappa is called conductivity. So if rho is resistivity, then your kappa is what? Conductivity. And these two are also reciprocal to each other. The way resistance and conductance are reciprocal, the same way specific resistance and specific conductance, resistivity and conductivity are reciprocal to each other. So this and this is also reciprocal to each other. Now, with the help of the unit of resistivity, specific resistance, we are going to find the unit of conductivity, that is specific conductance. So 1 is 1 again. So what is the unit of rho in CGS unit? The unit of rho in CGS unit is ohm centimeter. That only I am writing here, ohm centimeter. Unit of rho from here is what I am writing here is ohm centimeter. Now if this ohm goes up, become ohm inverse. If centimeter also goes up, become centimeter inverse. Therefore, if the unit of rho is ohm centimeter, then the unit of kappa will be ohm inverse centimeter inverse. Okay? Now you can see out here, students, centimeter inverse, centimeter inverse, centimeter inverse, centimeter inverse, I am keeping same. But I can replace this ohm inverse with omega inverse, with mho or with Siemens from here. You can see here, ohm inverse can be written as omega inverse, mho or Siemens. That only I have done here. So centimeter inverse I am keeping same in all the cases. I am just replacing ohm inverse with omega inverse, with mho and with Siemens. So this is the unit of kappa. So the unit of kappa is ohm inverse, centimeter inverse, omega inverse, centimeter inverse, mho centimeter inverse, or Siemens centimeter inverse. And you have to remember these all units, students, for the numerical problem or for the objective question may be asked from the units. Also you all understood. So from physics now we are entering into the chemistry. In physics it opposes the flow of current. In chemistry conductance allows the flow of current. Now this formula I am writing from physics. R is equals to rho L by E. R is equals to rho L by E. I have copied same to same from here. Now you know that resistance is opposite of conductance. So resistance reciprocal is what? Conductance. So if you keep this R up and this C down, so R will be equal to 1 upon C that I am writing here. And similarly rho, if I keep this rho up and bring this down, so the rho will become 1 upon kappa that I wrote here. So resistance can be written as 1 upon conductance and resistivity can be written as 1 upon conductivity. resistivity can be written as 1 upon conductivity, whereas L by A is same to same. So 1 upon C, 1 upon K is into L by A. So if this is the formula of physics, students, then this is the formula of chemistry. Done? Where C means conductance, unit is these all. This means specific conductance or conductivity, units are these all. But if you want to do in SI system, it will be meter inverse, meter inverse, meter inverse, meter inverse in SI. The first portion will remain same. Its SI unit will be meter inverse, meter inverse, meter inverse, meter inverse. That's it. Okay. So C means conductance, kappa means conductivity, and the units I have already shown you. Now what is this L by A out here in chemistry? In physics, L means length of resistance and A means cross-section area of resistance. That means in chemistry, this L means length of conductance then, and this means cross-section area of conductance? No, it's wrong. Okay, so in chemistry and physics, the meaning of L and A is different. Here L means length of resistance, but in chemistry this L means distance between two electrodes. I repeat again, in physics L means length of resistance, but in chemistry L doesn't mean length of conductance, it means distance between two electrodes. And when you say about distance, it's a length, so the unit will be centimeter or meter, CGS SI. Similarly, A out here doesn't mean cross-section area of conductance. In physics, A means cross-section area of resistance. But in chemistry, A doesn't mean cross-section area of conductance. In chemistry, A means cross-section area of electrode. You know that in an electrolytic cell, we give two rods. Those are called electrodes, which are of cylindrical shape. And this cross-section area of electrode I am talking about. Okay. So here L means distance between two electrodes in a shell, and A means cross-section area of the electrode. And since I am talking again about the area, so the unit will be centimeter square or meter square. CGS centimeter square, SI meter square. And when you talk about cross-section area of electrode, it has a circular base. When you talk about the cross-section area of an electrode, we are talking about circular base. And if it is circular base, the area formula will be pi r square, because it forms a circle. Circular base, cross-section area. So it looks like a circle. So the formula of the area of cross-section of electrode will be pi r square. Pi r square, in which you know that pi means what? 22 by 7, or you can say 3.14. Whereas r is the radius of the electrode, this cross-section area radius. The radius of this circular base is called what out here? R. So I have given you some meaning of the topics, terms right now, students. Hope so you all have understood that, and you should keep this in your mind. Okay. So far what we have done out here is that we came to know the topic under electrochemistry, which are the important topics. What does this chapter is all about? Then I taught you what is the meaning of metallic conductor, how they conduct electricity, and how the electrolytic solution conducts electricity. Then we went to physics for a while to know the character of resistance. After that, we came to the character of conductance. And now you have to remember the units of all of this along with the formula. So far only one formula is important to you, and that is ρ1. So rho is equals to ρ1, means resistance into area of cross section divided by the length of resistance. Okay, and do remember, area in chemistry means cross section area of electrode, which is pi r square. So students, if you want, you can take the screenshot of this. I hope you all have taken the screenshot. So I'm going to rub this then. Okay, now students, what we're going to see out here is we'll follow from here again. Okay, so I'm going to follow from here for you all. Okay, students, now this formula you check properly. As what I said, this is distance between two electrons, and what is this? Cross section area of the electrode. The cell in which we observe conductivity or conductance is called conductivity cell. Okay, is called conductivity cell. Where we observe conductance is called conductivity cell. Inside this cell, two rods are dipped, which is cylindrical in shape. Okay, which is cylindrical in shape, and they are connected with the what? Battery. They are connected with the battery. Now this distance between the two electrode is called L in chemistry. So what does this L means? Distance between the two electrodes. Okay. So distance between the two electrodes is called what? L in chemistry, and this circular base is called cross section area. That is A in chemistry. So in chemistry, L means distance between the two electrodes, and this means cross section area of the electrode. That is A, and since it is a circular base, so the formula will be pi r square. Hope so you remember this all, students. Now I'll continue from here. Okay, I'll continue from here for you all. You can see this last portion here. 1 upon C means what? Reciprocal of resistance, conductance. 1 upon C means reciprocal of conductance is what? Resistance. So 1 upon C means what? Only R. 1 upon C means what? Only R. That I wrote there. Now what is here? 1 upon kappa is there. You can see into what is here now? L by A. So what I've done so far is I just replace 1 upon C with R and keeping 1 by kappa as kappa and L by A as L by A. Hope so you all understood till here. Now let us take this one this side. So when you take this one this side is equals to R into kappa. Now what is left here is L by A is left. And here L by A means cell constant. Okay. What does L by A means? Cell constant. This gives us the new formula. Okay. So the formula for cell constant is R into kappa. Resistance into conductivity or specific conductance. And here just now what I said you, even L by A also means what? Only cell constant. L by A also what it means is what? Cell constant. So do remember, students, from here that cell constant has two formula. Okay. From here you have to remember that cell constant has two formula. One formula for cell constant is Rk. The other formula for cell constant is L by A. And it's not K. Actually we should say kappa, but right now I am saying it as K. So cell constant formula is 2. So what is the two formula for cell constant? Cell constant means Rk into La. Rk into La. Okay, for Chekhov. For example, cell constant means Rishi Kapoor went to Los Angeles for Chekhov. But unfortunately, he is no more now. You all know that he was suffering from cancer, so he died. So Rishi Kapoor went to LA for Chekhov. Okay. So what is the formula of cell constant? There are two formula from now on. Rk went to La. Distance between the two electrodes, cross section area of the electrode. Okay. So I have given you the two formula for cell constant. Now student, let us see what is this cell constant all about. From here we can define it. Okay, we can define from here. So cell constant means what? L by A. Cell constant even means L by A. So what is the unit of length, distance, centimeter? Area unit is what? Centimeter square. So when you cancel it, so if the centimeter goes up, becomes centimeter inverse. So what is the unit of cell constant? Centimeter inverse. But what if I put here meter and meter square? If I put up here as meter and down as meter square, meter square. Okay, meter and meter square. Then 1 meter and meter square will get cancelled, so it will become meter inverse. So the CGS unit of cell constant becomes centimeter inverse. You put both as centimeters, and its unit will be meter inverse if you put here meter and meter square. So this is the unit of cell constant. And here what is it? What does this L means? L means distance between two electrodes in chemistry. And what does this A means? Cross section area of electrode. And this becomes the definition of cell constant, students. So if anyone asks you what is cell constant, what you have to say? It is the ratio of distance between two electrodes to the cross section area of the electrode. So what is cell constant definition? It is the ratio of distance between two electrodes, to the cross section, area of the electrode, to the cross-section area of the electrode. Done, students? So remember the definition of cell constant for now. It is the ratio of distance between two electrodes to the cross-section area of the electrode. And its unit in CGS is centimeter inverse, in SI it's meter inverse. And do remember the unit for the numericals, I have already said you. So far in this class, we have to remember three formula. One formula is rho is equals to ρ1 for specific resistivity. Another formula you have to remember is for cell constant. Okay, so another formula which you have to remember is for cell constant, which means RK went to LA. Resistance, conductivity is equals to length, distance between two electrode, and cross section area of the electrode. So please remember this much, students. So if you want, you can repeat the video and you can go through these lectures, okay, one more time, and please make the note from here too. Thank you very much for today's class.